when Carly comes back. Okay. So let's go over this review real quick. You ready?
Yeah, I'm already recording.
Okay, so on the first one, domain and range, whether it's exponential growth or it's exponential decay, it doesn't matter. Your domain is always all real numbers because anything can go in for the exponent value. My range is always all the numbers that are greater than 0 because I'm always going to have an asymptote that runs right here on this line. So it's going to be everything that goes above it. Doesn't matter if it's curved the other way. Doesn't matter if it takes a long time to get there. This is going to be what we're dealing with. On the next one, the exponential function. You go into lists and spreadsheets on the calculator. You type in these values. You go to data and statistics. You run the exponential regression, and it's going to give you these values. Okay? When it does these values, if you rounded this one, that's probably okay if you were already working that with me today. Remember that your growth or decay, since these are going up, it's going to be growth. All right? So all I'm looking for is my distance from 1. Since it's 0.0275 above 1, I move that decimal 2 places to the right, and that is my percent change. So it's 2.75% growth. Okay? It shows it here again, moving that decimal 2 places. On number 3, the toy with the cylindrical rings. It's talking about it keeps 90% of the diameter every single time. My original one, the one on the base, is 7 inches. So that's 7 times 0.9 for every radius that we go up. So this is times 0.9 to get this one, times 0.9 again to get the next one, and so on and so forth the rest of the way through that one. It's not asking you to find the values, it's asking you to say what's going on every time, and we are multiplying by 0.9 because that 0.9 is 90%. On number 4, the exponential function for the table. Again, you can do the lists and spreadsheets. You can enter this into the calculator, or if you're thinking like we were doing on the sequences, you can just look and try to see what's happening every time. If we have this one to this one's a little more difficult, but this one right here, 25 cents times 4 makes $1. $1 times 4 makes $4. So we are multiplying by 4 every single time. The one across from the 0 is our starting value. That's our initial value right there. And my growth or decay, again, it's how far I am on this multiplier from 1. Since this is 4, it's 3 away from 1, which would be 3, and then we move 2 decimal places over, it's 300% growth. On number 5, again, put it into your table, your data and statistics. Take a look at what's going on and keep multiplying it out, or you can shortcut that by saying, okay, it's 6, and we're multiplying by 2 every time, so it's 2 to the number of months. So you can put 6 times 2 to the 10th power. Gives you 6,144 mice. But this will also work if you figure out the equation using the calculator steps and then put that into the graph, check the table, it'll work that way. On number 6, 789 cell phones, 2.25% means if I have the percent, I'm going the other way with the decimal, 1, 2. So it'd be 1.0225. I multiply that by that number of cell phones, it'll keep giving me the next month. On number 7, begins producing new parts. Data was collected on the number of defective per 10,000. So for the first 10 weeks, during which we were approximately 180, we just go across at 180, see where that is. That's going to be closest to 3 weeks. This is going to be a multiple choice test. So it's going to have this graph, hopefully I can get it on there, it's going to have this graph sitting across here, and it's going to give you options. Follow those options up, see where they cross, and see which one is going to be the closest to the right answer. On number 9, this one's already set up like multiple choice, so you can expect this one on the test. A part-time office worker earning $5,000 to start, so make sure it starts at $5,000. This one and this one don't, they're gone. We know it's exponential, so it has to curve, okay? But you gotta look at which one's gonna make sense. An increase of 6.2% is not times 6.2. It's times 1.062. So we start looking at those values. You could even go on your graph, pull up the table, and see which one matches up better. Pay close attention to these values on the side. Okay, your starting graph, it might look like this because these values are pretty large to start with. But it's probably going to be this one here, a more gentle curve, because 6.2% is not a huge amount. Okay, number 10, how much is going to be occupied by the cane toads X years after it was introduced? Here's my table. I can put in my table. Here's my graph. I can look at my graph. So if it's looking for 50 years, that's off my graph. But I know it's going to be a ways up here. Again, this is a multiple choice test. So if you can't figure anything else out, get on there, find the ones that already exist, and cross them off. It's not going to go back down. It's only going to increase, and it's increasing exponentially. So if it says, well, what about 600,000? No, because we'd have that in like 36 years. It's going to take us longer. And if they have like 115,000, that was at 15. Cross it off. It can't be a right answer. Number 11, again, you can type this into the calculator on the graph and check the table and find out when it's going to get to 5,000. In this case, it's between 54 and 55 minutes, and that's just scrolling down on that table. Control T pulls up your table. On number 12, change in value of a car. We know a car gets to be less and less over time. The correct answer on this one, and right off the bat, these two, it loses half of its life, a quarter of its life. What is it, a video game character? Okay, it's not life that it's losing, it's value. So when it's losing its value, does it lose more at the start or over time?
Over time.
And it's definitely, it loses a lot up here. From 1 year, from 0 to 1 year, that's a big jump. From 9 to 10 years, it's like $500 maybe. So it lost less value between 9 and 10 than between 1 and 2. Here's 1 and 2. That's a decent jump. Here's 9 and 10. It's almost nothing. Okay. Number 13, and determine the sequence. 5, 20, 80, 320. We are multiplying by 4. Just remember, this is my first term. So I have to back up a step to get that initial value. That's 5/4. Okay? If we divide 5 by 4, it doesn't go evenly. So 5 over 4, or 1.25 if you were doing decimals, times 4 to the n power. Number 14, simplify. These are the ones that we had before. Factor the number out, group together the m's, group together the n's. There's a workaround for this with the calculator. If you put a number like 2 in for m and 3 in for n, you can just type it in and see what you get. Write that down. And then go through the answers, use that exact same number, 2 for m and 3 for n, and see what number you get from all of the answers. Only one of them should match up. And that's going to be the one that has these exponents there in the right way. On the 11th, there's 5 on the outside, 1 left on the inside. On the 12th, it's all 6 to the outside. And 300 isn't a perfect square, so it's not going to be everything on the outside. Remember, a group of 2's is a single 2 on the outside. A group of 5 is a single 5 on the outside. 2 times 5 makes 10. On number 15, simplify the expression. If it's to the -2, we're flipping the whole thing, and then we're going to square it. And then this n is to the -6, so it's going to flip. But don't worry about your numbers. 5 over 4 is 5 over 4. When we go to square that, 5 squared is 25, 4 squared is 16. Now, if it's anything like this, where this one's going to travel across and your m and n are going to be on the same side, you're going to look for an answer that just has a number on a multiple choice. Okay? Just the number up on the top. Number 16, no, that's it. There are only 15 questions on this review. If there was any part of it that you didn't understand, something that you didn't get, I have tutorials tomorrow morning. Mr. McLaughlin's doing tutorials after school today in his classroom. Get the help that you need before you show up to take the test.